How's it going, everyone? In today's video, we're finally going to start learning about the match control flow construct in Rust. And match allows us to compare a value against a series of patterns and then execute code based on which pattern matches. And there's a lot we can do with match. So let's get started with a quick example of what it looks like. And actually, before we do anything, we're going to create an enum called data size. And this will hold byte, kilobyte, megabyte, and gigabyte. Then we will create a function called bytes. And this function will convert the data size that we select to bytes. So here we'll type in size and specify that to be of type data size. And we will return a U64. Now to use match, we need to use the match keyword, followed by the expression we want to match against, which in this example is going to be the size. And now when the match expression executes, it's going to compare the resultant value against the pattern of each arm inside this match expression. And I'll explain what an arm is in just a second. So first we need to cover what should happen if size evaluates to a byte. For example, here we can type in data size of type byte, and we can use this arrow to separate the pattern from the code we want to run. In this example, we just want to return 1 byte if we use the data size of byte. Otherwise, we can add data size kilobytes with an arrow, and that's going to return 1000. Then we have data size megabyte, which will return 1000 times 1000, and data size gigabyte, which will return 1000 times 1000 times 1000. Now, each one of these are called an arm. And this match expression has 4 arms. Now let's use our function to convert 1 kilobyte into bytes. So here we're going to type in let kilobyte equal bytes, and we're going to pass in data size kilobyte. Then we can print line, or I'm going to use my special debug statement to pass in the kilobyte. Now we can open up the terminal and type in cargo run in quiet mode. And what we should get as an output is that 1 kilobyte is equal to 1000 bytes. And this was all possible thanks to our match expression. Here we inserted data size of type kilobytes, and that was transferred here. So once it found it inside our match expression, it was able to use that arm to return the result of 1000. Also, in this example, we decided to only return 1 value for each arm. But what if you want to run more lines of code and return another value based on that code? Well, for each arm, you can also choose to specify curly brackets. And this allows us to add multiple lines of code. For example, for the first arm, we can type in something such as 1 byte is 1 byte mate. Because, 1 byte is 1 byte. And then we can return 1 at the bottom of this block. And now if we go back to our main function and change this to byte, and change this to B and B, you'll see that when we run our code, that we will get the following output. 1 byte is 1 byte mate, and B is going to equal 1. And we can do this for every single one of our arms. They don't have to be in order. You can also choose to add an arm here, say 1000 times 1000, and print something else. That works as well. You can add this anywhere you want inside your match expression. Also, you are not required to use a comma when you are using this syntax. The code will run exactly the same way whether you specify a comma or not. It is completely optional. Anyway, let's change this back to 1 because it's time we move on to the next example, which will teach us about patterns that bind to values. So for this next example, we need to go to our enum and specify that gigabyte is going to be of type U64. So now it takes a U64 as a value. And you'll notice immediately that we're going to get some syntax highlighting inside our match expression. And that's because we need to supply the U64. So here we can insert a variable name that will absorb that value. Or not only absorb, but it's going to allow us to use it as a variable inside this arm. So here we can type in amount, just as an example. It doesn't have to be amount, it can be literally any variable name you want. You can even type in var, or let's say value. Whatever you want to insert there, you can do that. But for this example, I'm going to keep it as an amount. Now with this, I'm going to create a block because I want to execute some extra code. And I'm very upset it took away the 3 1000s. So let's keep that and tap on enter. And then I'm going to type in let total equal all of these times the amount. Because what we want to do here is specify an amount of gigabytes and return the conversion in bytes. And of course it's going to complain, but at the bottom what we want to return is the total. But before we get to that total, I also want to print some text that tells us exactly how many bytes that is in billions. So let billions equal the total divided by 1 billion. Then we can print line that the amount in gigabytes is billion bytes. And that will just make it a bit more legible because this is a lot of bytes we're dealing with. Now to actually use this, we need to go back to our main function and create a new variable. And this one's going to be called 2 gigabytes, which will equal bytes, and that will take a data size of type gigabyte, which will take an unsigned integer of 64 bits. So here we can type in something such as 2, and we can do another one that says 5, and another one that says 25. So here I'll type in 5 and 25. And finally, we can debug this and pass in 2 gigabytes. And we'll do the same thing for 5 gigabytes and 25 gigabytes. Next, we can open up the terminal and run this one last time. And what we're going to get as an output is the print statement for each one of these plus the actual value. So 2 gigabytes is 2 billion bytes. 5 gigabytes is 5 billion bytes. And you can see that down here. But as you can see, this is quite illegible. So it can be nice to have this print statement to make things a bit more clear. But what's important here is that we were able to extract this value and use it as part of the pattern inside our match expression.